All right, guys, so first thing we're going to jot down are some strategies for evaluating limits. Last time, most of what you did was evaluating the limit by looking at the graph. Today, you're going to be doing most of it algebraically. Okay? So, your first strategy is just direct substitution. So what I mean by that, let's say I give you the limit as x approaches 2 of x plus 1. What is x plus 1? Like, what's it a graph of? It's a line, right? Just a nice continuous line. So you could think about graphing it and then go to where 2 is and approach from both sides. But isn't it just going to be what the y value is when x is 2? Yeah, so you just plug 2 in and say, okay, the limit is 3. So if it's something that you can plug it in and you don't get an undefined value, just plug it in and be done with it, okay? So those are the simplest ones. Another strategy is to factor and reduce.
Like factoring.
You don't like factoring?
When it gets to like x to the 4th or x to the 5th.
Okay. How are you guys on your cube factoring? Okay, all right. One says no. Soap. Yeah, can you tell? You all remember soap, but do you actually remember what it stands for?
Same opposite, always positive.
Oh, okay, much better. Second period was like, they knew soap, they didn't know anything else. So, you guys are ahead of the game. Basically, what you're doing if you're factoring and reducing. So if you look at something like this, do you see how just plugging the 1 in would be a problem? Yeah, we don't want a 0 in the denominator. But if I reduce it, essentially what I'm doing is like getting that hole out of there, and then by plugging it in after, you're finding where the hole is. Because remember the limit, we walk right up to the hole, but we don't fall in the hole. Okay, so that's what you would be finding there. So you reduce, and then tell me, oh, that's 3. Plug the 1 in. So what, like after I've reduced, then I can plug in what x is approaching. Yeah. Okay. Questions? Oh, okay. You're good. Good with this. Okay. All right. Third strategy is rationalize. And that we're just going to do a full example with because it's kind of not always the rationalizing you think of. Sometimes we put a square root in the denominator when we do it to make it something we can actually find the limit of. So I'll just show you an example. All right, so let's go through a couple of examples here.
Is the one we're going to see the most?
No, you see, it's just, it's such a variety of what you see. It's being able to recognize, like, that's the easiest path to get to the limit. All right, so this one, let's do the limit as x approaches 3 of square root of x plus 1 minus 2 all over x minus 3. Real pretty. All right, so can we just plug the 3 in? No, everyone see why that's no good? Okay. Now, I see a square root, so that makes me think rationalize. Even though the square root's not in the denominator, we can still use the rationalize strategy. What do you think I might want to multiply numerator and denominator by?
X plus 1 plus 2.
Yeah, square root of x plus 1 plus 2. Now don't get ahead of me because you're going to do too much work. All right, so your next step, you have to write limit as x approaches 3 again. And then we're going to look at what we have when we multiply. Okay, the numerator, because those are the conjugates, I am actually going to multiply those out. So what is square root of x plus 1 times square root of x plus 1?
X plus 4.
All right, we're good at that. Good work, guys. And then do you see how it's going to be positive 2 square root of x plus 1, negative 2? Okay, that's the whole point of the conjugate, right? So then the last term would be minus 4. All right, then the denominator. Do not multiply out the denominator, okay? You'll just be looking at it and going, I don't know where to go from there. Leave it as x minus 3 times square root of x plus 1 plus 2. I know it looks weird, but I promise it will make it so much easier. All right, so new step, we got to write limit again. You have to write the limit in every step, okay? Notation matters. All right, so the numerator, do you guys see how that's just x minus 3? So what can I do? Yeah, get rid of those x minus 3's, right? So I am left with 1 over square root of x plus 1 plus 2. Okay, what do you think I can do from here? Now I can plug in 3, right? You don't have to rationalize again, guys. Okay, that would just get you back to where you started. We've eliminated what was causing us the problem as far as plugging things in. So I can now say equals 1 over square root. No, it's interesting, right? So are we getting an answer of 1/4? Okay. All right, so notation. I have to have the limit statement here. I have to have the limit statement here. I have to have it here. Why do you think I don't have it in this one? That's where I've plugged in the 3, right? Okay, so I'm not going to take the limit of this now that the 3 is already in there. You have the limit all the way through until you plug it in and then show what it simplifies to. Okay? All right, questions on that one? Second one. Limit as x approaches negative 3 of x squared plus x minus 6 over x plus 3. X approaches negative 3, denominator is x plus 3. Can I plug it in? No. What do you think we're doing on this one? Factoring, yes. So I'm going to have x plus 3 times x minus 2 over x plus 3. Reduce, right? I can just go right to the plugging in then. So then I've got negative 3 minus 2. Negative 5 is my answer. Okay? Not bad. One more before we get to the other part of the notes. Okay, a little bit of trig stuff here. Trig quizzes will come back.
Wait, when are they gonna start having like more stuff? Just
Sometime this quarter. The majority of it is always just the trig value, so even when I put other stuff on there. Okay, if I try to plug in 0, what is the sign of 0? 0. So I get 0 over 0, right? That's no good. Anytime you see that, you should think, oh, no, okay? Don't do it. All right. This is one that, unfortunately, there is no algebraic way to see it. So if we looked at the graph, we would see that it approaches 1. But this is one that you just have to know. There's 2 trig limits that you just have to know, and they're the first thing we're going to fill in on your next note page. But just know that's one of them. Okay?
What if it's sin x over 2x? What does it point out?
F and C. I don't know. It's a good question.
Because you guys were like, I thought it was boring.
You're boring.
No, the first one. You said it was boring. You didn't copy.
Yeah.
It is over. Can 2 sin x over x is that 2?
Why are you like this?
Because it's definitely stretching out your graphs against you.
Oh.
So if it was 5 sine x over x, it'd be 5.
Dang, I just found a new trig I never did.
Well, kind of, but you can see like it's not the normal graph. Like it like rises on the y-axis. Otherwise, it's very weird. Okay. All right. Side note there, guys. Okay. So let's get to somewhere here your actual notes. Okay, guys. So first thing you're filling in for me, and then I'll start erasing. So the one we just talked about, as x approaches 0, sine of x over x, that limit is 1. If it happens to be the limit as x approaches 0 of 1 minus cosine of x over x, that is 0. Those are the 2 you have to know. All right, guys, so we're just going to practice evaluating some of these limits with the different strategies on this first page here. So the first one there, limit as x approaches 2, and then you have that big fraction. What do you think? Can I just plug the 2 in?
Yeah.
Yes. Do it without a calculator. I am not kidding. Do it.
32. 48 minus 4 is 44. 32 times
That better. That's a little better.
40.
Solomon.
Do it yourself, guys.
Be quiet. What are we doing?
No, we're still adding and subtracting.
Yes. Yes. 213 over 51.
That is correct. You survived without a calculator, guys. Maybe we're not. We haven't survived yet. Okay, still getting there. Are you making it difficult? Sis?
I forgot what was
Oh, I got 416. That one memorized. Excuse for 8, 6, 33. Treatment. 4, 8.
Did we get there? Yeah, we made it.
Good job, yeah.
All right, try number 2 for me. What do you think you have to do on that one? Back or yes.
Wait, this we just do this.
Opposite signs or like opposite denominator, I think, but very similar, yes.
You're not gonna write anything, right? Yes, I do. I remember last night. Oh, now we get to do so same.
Yes, guys, all right.
We literally talked about so
Same, opposite, always.
Yes.
Oh, for
Yeah, try 3 factor. If you forgot cubing factoring, there you go. What do you mean what? That should not be a new concept for you.
What did you say?
I forgot about this.
Said if you forgot how to factor cubes, here's your rule. If this is the first time you've ever seen this, I'm a little concerned.
It's not the first thing.
Okay. Second time.
1 minus 1, 0.
The answer to it is not 1. You may want to reference the factoring guidelines up
Oh,
here.
whatever. Oh, God. It's 3. It's plus. It's not minus.
Ew.
Same,
What?
opposite.
Oh, minus.
No, it doesn't show negative. This is so. Right.
Welcome to the day. Yes.
I love so.
Oh, it's kind of loud.
It's just that kind of day, guys.
Four, 2, 4, 4.
It is 4. Wait, key factor just means you places.
What?
It's only difference of squares that is the difference. Cubes is just.
Really, every factoring test I had a hard time figuring out for too. I don't know why.
All right, guys. Biggest thing on this is make sure your notation is good. Make sure you're writing that limit statement when you need to.
We have to show our work that.
Like for this one, for 3? Yes.
What's an historical person starting with Y?
What's a what?
Starting with a Y?
Super math related. All right, guys, everybody okay on 3 when you're factoring? I know we're kind of just rolling through these. Are we okay? Pace, we're doing okay? All right, so number 4, what do you think you have to do on this one? Rationalize. All right, go for it. Don't multiply too much. Don't do more work than you have to. For number 4.
Yeah, just 0, 0. No, name's not 0.
What are you talking about? No. Yeah. You can factor 4 too, also. Yeah, absolutely. Yep, that way works too. 5, you'll have to do the rationalizing way though.
Yeah.
Okay. Yes, it is.
No, we didn't learn that.
And learn what?
X over X. Oh, wait.
That one's definitely the trickiest up here.
No, we have to do sort of like. Oh, wait. It's cosine X y.
Wait, you don't even have to plug anything in Mars. What? No, wait. No, this is, oh my god. Same as 0. It still doesn't, it's still undefined.
You have to
Wait,
Yeah, there's a lot to do on 6. We'll do that one together. I just want to give everybody a chance to get through 4 and 5 first, okay?
I'm such an idiot. I literally forgot the most important step. 1 day, not 0.
In 1 day.
Yeah.
Yeah, 1 day. Oh no. Here?
Now it's gonna crack.
Stop. What if I motion speak?
What was that? Just Bank of America.
It's evolving.
Yeah, because we're making sure they don't fail.
After you know.
You know what? So lucky still has 6.
I had a friend in middle school who would say when I was like I was there, I just like both of her fourth and fifth.
See how you probably know that. Considering I don't get to spend any words or do anything, probably not.
All right, guys, number 4, you should have gotten 4. 4, 4.
Eating off other people's food.
Did you forget your lunch out?
No, we have like this senior night.
Oh, okay. All right, guys, did you get 1 pass for number 5? Yes? Okay. All right, are we all on 6? Okay, let's talk about 6 together, because it is different than the others, obviously. All right, so let's start. I heard some of you say turn tangent into sine over cosine, and that is an excellent place to start. Now look at how I'm writing this. Do you agree that that is what the original, like, that equals the original? Yeah, you see it? Aiden, do you see it? So let's think about it. Because you get tangent sine over cosine. Were you thinking that? Look up here for a second, Aiden.
Yeah.
Okay, well, I can put x over 1, right? Follow with me here.
I
So then think
understand.
if I flipped, that that's where I would end up. That's more useful than a, like, 3 or 4 tiered fraction, okay?
Not if you're going to use fraction.
All right, then I'm going to kind of reorder this.
Sine x over x.
She just said it.
Okay, does that make sense? Isn't that the same thing?
Yeah.
Multiplication, I can move stuff around like that.
Oh.
All right. Sine of x over x, that's something we know something about, right? Okay. But we do have to split this up before we can evaluate that part of it. So what I'm going to do is do the limit as x approaches 0 of sine of x over x times the limit as x approaches 0 of 1 over cosine of x. It's a property with limits. You can take the limit of the pieces and then multiply them together. Okay? So, the first one we know from notes earlier today. What is the limit as x approaches 0 of sine of x over x? 1 times. What if I plug 0 in here? What's the cosine of 0? 1. And what's 1 times 1? Okay. There's your answer. You are like 1. Alright, questions on that? You understand how you have to kind of just manipulate it and to turn it into something that you can actually work with?
It's getting abstract.
You what?
It's getting abstract.
A little bit. I get into calculus stuff.
What is the 1 over cosine of x?
What is the cosine of x? Or I'm sorry, the cosine of 0?
Stop.
Oh, it's yeah.
Oh my god, I had mango, I changed it, and all of a sudden Magnolia was gonna do that, but then I didn't, it's not. Because I just had mango, and I got it wrong.
Alright guys, let's go through these sort of weird looking questions if you turn the page. We've got some multiple choice, we've got some funky graphs going on, some piecewise. Alright, number 7. I want to know the limit of f of x as x approaches 3, and then I'm given this piecewise equation. Okay, if you really like graphing piecewise functions, yes, you can draw it and look the limit from the left, the limit from the right, do they run into each other? Or you can just plug in the 3 to evaluate the limit from the left, the limit from the right, and see if they're equal. That would be my choice, yeah. So when I plug a 3 into the first piece, what do I get? 9. And when I plug a 3 into the second one? 14. Are 9 and 14 the same thing? Pretty much, yeah, they're kind of close. Wow. Not exactly the same. So, does not exist is your answer.
Are you allowed to just say that? Or
Yes.
do you have to like do the bullet points?
Am I asking you continuity? No. Okay. Only on the continuity test would you have to go through the 3 rolls. Okay. All right, number 8. So now I want to know the limit as x approaches 2 of f plus g of x, and then I gave you 2 graphs. All you have to do is find the limit for each of them individually where x approaches 2 and add them together. So it looks much worse than it is. So in that first graph, what is the limit as x approaches 2? 1. Is everyone, are you guys all okay with the dot means nothing to you right now? Okay, so this is 1 plus, what's the limit at 2 for the second one?
3 graphs.
So our answer is 1.
Make the graph.
How do you make that graph?
Yeah. 1.
I mean, you could do like a weird piecewise graph with 2 square roots that are flipped and shifted. All right, we okay with that? Okay, let's look at 9. All right, again, piecewise. And I want to know if the limit as x approaches 4 exists. Does that matter? No, because think, right? If we had a graph with, okay, here's 4, and I have a hole, you could still meet on the edge of the hole, right? Okay. Clearly that's not the graph that goes with this, but. All right, what do you think? When you plug 4 into the top one, what do you get? 0. When you plug 4 into the bottom one? So does the limit exist? Yes. And if you wanted to, you could tell me the limit of f of x as x approaches 4 is 0.
You have to do all the tests you just did.
Well, if the question just says, does it exist? So really, yes is all you technically have to say. Yep. These are from old AB Calc tests. So if you were wondering when we were getting into the calculus, we were clearly there, guys. Okay. All right, so f of x equals 2x squared plus 1, and I want to know the limit as x approaches 0 of f of x minus f of 0 all over x squared. Okay, yes, welcome to calculus. It's not that hard. You just have to interpret what it's asking you. So I'm going to start with the limit as x approaches 0. Then it says of f of x. Well, do I know what f of x is? Didn't it tell me? 2x squared plus 1, right? And then it says minus f of 0. Well, what's f of 0 going to be? We're just going back to this. 1 all over x squared. Everybody see where I'm getting those pieces from? Okay. So then I'm just going to simplify. Limit as x approaches 0. That's just 2x squared over x squared. So my x squareds cancel. What do you think the limit is? 2. Okay. Realize what that's asking you is it's talking about the line y equals 2. So think about that. Anywhere I am on this line, what is the y value going to be? 2. So no matter what x is approaching, the limit is going to be 2. Okay. We're skipping 11, guys. 12 still has natural logs, but it's easier. Everybody okay with 10 before I scroll down? Okay. 12. All right. Give you this lovely piecewise with some natural logs going on in it. And then I'm asking you about the limit as x approaches 2. What do you think I should do? Plug it in? Yeah, right? Isn't 2 a breaking point essentially on the piecewise? Like, yeah, so let's see if those are equal or not equal. That's really all we care about. So I get natural log of 2, and I get 4 times natural log of 2. Okay, so even if you're panicking and going, I hate natural logs, can you look at it and say, well, I'm pretty sure those are not equal?
Yes.
Okay, so what's the answer?
Non-existent.
Yes, non-existent means does not exist, okay? All right, okay with 12. 13 is not 0. All right, let's look at 13. Okay, so this time we're looking at the limit as x approaches a. Could I just plug a in? Like, what does that mean? So that would become a squared minus a squared, okay, over a to the 4th minus a to the 4th. You get 0 over 0. Remember? Oh, no, don't do that, okay? So I can factor, though, and simplify this. Now, don't go nuts with your factoring. I'm going to leave the numerator alone.
Oh, wait.
Whoa.
I got it.
I know. Pretty wild here. So my denominator, though, is going to be x squared minus a squared times x squared plus a squared. You could have gotten there if you factored the numerator, too. You'd just have a whole lot more terms to work with. You guys see what cancels? So then I've got the limit as x approaches a of 1 over x squared plus a squared. Yeah, now I can plug it in. So I have 1 over a squared plus a squared, which is 1 over 2a squared. Okay? Questions on anything?
What if you get like 0 over?
That is 0. Yeah, that's okay. Yep. Yeah, good question. All right, guys, turn the page. I believe it says classwork for you, right? Okay, so we're going to go through all 10. You guys start on it, and then at some point after lunch, we'll go through the answers to this, but I just need you to do some more. 11:30, so 5 minutes. Yeah. Yes.